Hello, my dear friends. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Myself Kodam Naveen Kumar, ನಿಮ್ಮ chemistry faculty. I welcome you all to this incredible platform Physics Wala. Okay, now in our equilibrium chapter, last class ಯಾವ ಚಾಪ್ಟರ್ ಮುಗಿತು? ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ, ಆ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಲೆಕ್ಚರ್ 2 ಮುಗಿತಲ್ಲ. Now in this equilibrium it has been divided into two parts ಅಲ್ಲ, ಒಂದು ionic equilibrium, ಒಂದು chemical equilibrium. First we have seen the chemical equilibrium, lecture 1 and the lecture 2 we have seen. Now today I am going to start ಯಾವ ಚಾಪ್ಟರ್ ಅದು? Ionic equilibrium, chemical equilibrium and the ionic equilibrium. Chemical equilibrium ಖತಮ್ ಆಯಿತು, ಮುಗಿತು, and today we are going to start the ionic equilibrium. Now let's start our ionic equilibrium. Now ionic equilibrium chapter start ಮಾಡೋಕ್ಕೆ ಮುಂಚೆ ನಾವು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಏನು ಕಲ್ತಿದ್ವಿ ಒಂದ್ಸರಿ ರೀಕ್ಯಾಪ್ ಮಾಡೋಣ. ನಾವು ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಇನ್ ದ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಫಸ್ಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂದ್ರೆ ಏನು ನೋಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಲಾ ಆಫ್ ಮಾಸ್ ಆಕ್ಷನ್, ಲಾ ಆಫ್ ಮಾಸ್ ಆಕ್ಷನ್ ನೋಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ KP and the KC ನೋಡಿದ್ವಿ. KP and the KC ನೋಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಏನು ನೋಡಿದ್ವಿ? ರಿಯಾಕ್ಷನ್ ಕೊಯಿಷನ್ ನೋಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಏನು ನೋಡಿದ್ವಿ? ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್. ನೋಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಏನು ನೋಡಿದ್ವಿ? ಲೀಚಾಟ್ಲಿಯರ್ ಪ್ರಿನ್ಸಿಪಲ್ ನೋಡಿದ್ವಿ. Okay, now these are the topics that we have seen in our chemical equilibrium. Now in this ionic equilibrium, now ee video dalli in this ionic equilibrium, now what are the topics we are going to cover? Now what are the topics we are going to cover? That is, first is ionic equilibrium andre enu. Ionic equilibrium andre enu, that we are going to see. Next, Ostwald's dilution law. Next we are going to see the Ostwald's dilution law. Next, common ion effect. Next, Herous acid base theory or concept. Herous acid base theory, ಇದರಲ್ಲಿ Herous acid base concept ಅಲ್ಲಿ now we are going to see Arrhenius acids and base, next Bronsted acids and base, and Lewis acids and base. Okay, next we are going to see ionic product of water. Okay, ionic product of water. Next we are going to see the pH. Okay, power of hydrogen. Now these are the topics that we are going to cover in this video. Okay, now let's start our chapter. Next, ionic equilibrium. Now introduction eno ionic equilibrium ge. See, equilibrium is established between ions and unionized molecules. Such type of equilibrium is known as the ionic equilibrium. Ions and the unionized ions. Andre here AB gives rise to A plus and the B minus. Equilibrium is existing between the ionized and the unionized molecule. That type of the equilibrium ಏನಂತಾರೆ? Ionic equilibrium. ಈಗ ಇದು ನೋಡಿ, this substance which gives ions in molten state or in solution is called electrolyte. It is a substance which give the ions in the molten state or in a solutions, that we call it as a electrolyte. Here we are having the two types of electrolytes. One is strong electrolyte, and the second is weak electrolyte. One is strong electrolyte, one is weak electrolyte. Now strong electrolyte andre eno, weak electrolyte andre eno? Now let's see. Now strong electrolyte andre enandre, now it will completely ionized in the polar solvent. In the polar solvent alli completely ionized. Example H2O, completely ionized. Means it's alpha andre degree of dissociation is we can say it is not 100%, almost it will be greater than 95%. Alpha is 100%. Example, no, ಈಗ ಇಂದು NaCl ತಗೊಂಡಿದ್ದು ಅಂದ್ರೆ, now it will be converted into Na plus and the Cl minus. NaCl is a strong electrolyte. Examples for the strong electrolytes ಏನಂದ್ರೆ, that is strong acids, strong bases, and the salts. Now the salts also will act as the strong electrolytes. Now in that salts, what it should be there? In that salts, cation or anion. ಈ salts ಅಲ್ಲಿ ಏನಾದರೂ ಒಂದು cation or anion, if it is came from strong acid or strong base, no, that salt will act as strong electrolyte. Okay, that salt will act as a strong electrolyte. Best example, sodium acetate. Now sodium acetate, it will be dissociated to the acetate ion and the Na plus alla. Now this Na plus has came from the strong base. Came from the strong base. Adigoskara this is the strong electrolyte. Now NH4Cl, NH4 ammonium chloride, it will be dissociated as a NH4 plus and the Cl minus alla. Now the Cl has came from the strong acid. At least one ion. Idralli at least one ide. Either it may be cation or anion. If it is came from the strong acid or strong base, that will act as a strong electrolyte. Okay. Now example, HCl, H2SO4. Now perchloric acid, HClO4. Now NH4Cl. Now next HNO3. Now sodium acetate. Next Mg, magnesium hydroxide. Now sodium hydroxide. Okay, barium hydroxide, so on. Okay, next we are going to see weak electrolytes. Weak electrolytes ಏನಂದ್ರೆ it is not completely ionized in the polar solvent. Example H2O. Okay, now its alpha value will be less than 5%. Alpha value will be less than 5%. Its alpha value will be less than 5%. Example ಇಲ್ಲಿ ನೋಡಿ. Now ಏನಿದು acetic acid ಅಲ್ಲ, acetic acid is a weak acid. Now it will be dissociated into acetate ion and the H plus and the H plus. Okay, now examples for this one. Examples for the weak electrolyte ಏನಂದ್ರೆ weak acids, weak bases and the salts. ಯಾವ್ದು salts? sparingly soluble salts. Sparingly soluble salts also will comes under the weak electrolyte. Weak electrolyte degree of dissociation is less than 5%. Its degree of dissociation is less than 5%. Examples weak acids ಏನು CH3 COOH, next ammonium hydroxide, next ammonium cyanide, next benzoic acid. Organic acids also will call as a weak acids. Now these are the examples for the weak electrolyte. Weak electrolyte. Strong electrolytes completely dissociate ಆಗುತ್ತೆ. ಅಂದ್ರೆ it will whatever the ions it is present. ನಾವು ಈಗ 1 mole of NaCl ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ now that 1 mole of NaCl ಏನಾಗುತ್ತೆ, it is completely converted into ions. It is 1 mole of Na plus and the Cl minus it will be formed. That is known as a strong electrolyte. Weak electrolyte ಏನಂದ್ರೆ ಈಗ ನೀವು 1 mole of weak electrolyte ತಗೊಂಡಿದ್ದು ಅಂದ್ರೆ ಇಲ್ಲಿಗೆ ನೋಡಿ this acetic acid now it will be converted into COO minus plus H plus ಅಲ್ಲ. Now ಈಗ ಇಲ್ಲು if 1 mole if you have taken 1 mole of acetic acid, if you have taken only 0.001 mole of acetate ion and the 0.01 mole of acetate ion has been formed. The remaining will be in the reactant form alla. Remaining will be in the reactant form. So that type of dissociation we call it as a weak electrolyte. The weak electrolyte, it will not be completely dissociate. Okay, now next degree of dissociation ಅಂದ್ರೆ ಏನು? fraction of total number of molecules which dissociate into ions. Degree of dissociation is equal to number of moles dissociated by number of moles taken. Now see, maximum degree of dissociation alpha will be equal to 0. Minimum it is 0, sorry. Minimum degree of dissociation alpha is equal to 0 and the maximum degree of dissociation alpha will be equal to 1. Now here ಇಲ್ಲಿ ನೋಡಿ weak electrolyte ತಗೊಂಡಿದ್ರಂದ್ರೆ now it will be converted into acetate ion and this is a H plus ಅಲ್ಲ. Okay, now here if I take the 100 moles of acetic acid, now ಇಲ್ಲಿ only 0.1 mole and the 0.1 mole of acetate ion and the H plus ion if it is formed. Now the remaining will be 99.9 mole has been left as the reactant only, right? left as the reactant only, right? Only 0.1 mole, only 0.1 mole has been formed in the ions. Idralli 100 mole tan tagondidre andre adlinda only 0.1 mole has been converted into the product or ions. Means ilindra alpha andre it is converting into ion. Degree of dissociation, ಎಷ್ಟು dissociation ಆಗುತ್ತೆ. Now ಇದರಲ್ಲಿ dissociation is ಕಡಿಮೆ ಅಲ್ಲ, less, right? So here the remaining will be the 99.9 moles has been will be in the reactants only. Now if you take the strong acid HCl, if you ತಗೊಂಡಿದ್ರ ಅಂದ್ರೆ now HCl ಈಗ if you take the 1 mole, now 1 mole if you have taken, now strong acid ಅಲ್ಲ, strong acid completely dissociate ಆಗುತ್ತೆ. ಈಗ ನೀವು 1 mole ತಗೊಂಡಿದ್ವು ಅಂದ್ರೆ 1 mole will be converted into H plus and it will be converted into Cl minus. 1 mole of H plus will be formed and the 1 mole of Cl will be formed. Okay, 1 mole of H plus will be formed and the 1 mole of Cl will be formed. ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀರೋ ಅಂದ್ರೆ ಎಷ್ಟು, how much you have taken, that it will be formed in the ions. Now ಈಗ now 1 mole you have taken, right? Now after converting into ions, now the 0 moles of HCl will be there. Means that's the reason alpha for the strong electrolyte will be equal to 1. Now alpha value for the strong electrolyte will be 1. For the weak electrolyte will be less than 5%, less than 5%. Now this is the degree of dissociation. Maximum value for the degree of dissociation will be 0 and the minimum will be 0 and the maximum will be 1. Now degree of dissociation, now the degree of dissociation alpha will be affected by only 2. Now here the degree of dissociation alpha value will be affected by the 2. Now if we increase the temperature, alpha value increase ಆಗುತ್ತೆ, alpha value increase ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ ಈಗ this acetic acid, now for this initially it has been dissociated into 0.1 and the 0.2. now ಈಗ for this one acetic acid ಗೆ ನೀವು ಬಿಸಿ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, by absorbing that heat more the dissociation will happen ಅಲ್ಲ, means from the 100 moles it has been converted into, let us assume 0.10 mole. ಈಗ 0.10 mole ಆಗಿದಂದ್ರೆ now degree of dissociation alpha is increasing ಅಲ್ಲ, alpha is increasing. Now means if the temperature increases alpha is increasing. Next alpha if it is increasing, degree of dissociation increase agidandre volume is also increase. Now how the alpha is increasing, if the degree of dissociation increase agidandre how the volume is increasing. This was explained on the basis of Ostwald's dilution law. This was explained by the Ostwald's dilutions law. Now ಇಲ್ಲಿ ನೋಡಿ Ostwald dilutions law ಅಂದ್ರೆ ಏನು, the molecules of an electrolyte in a solution are constantly splitting into ions and that ions are reuniting to form the unionized molecule. Therefore a dynamic equilibrium exists between the ions and the unionized molecules in the electrolyte. ಇಲ್ಲಿ ನೋಡಿ now AB is converting into B plus, now it is converting into A plus and the B minus, For this here it is AB is splitting into ions, again this A and B is reuniting to form the AB. Now illinda now Ostwald ಏನು ಮಾಡಿದಂದ್ರೆ this above equation ಗೆ applied law of mass action, applied law of mass action. ಈಗ above reaction ಗೆ law of mass action apply ಮಾಡಿದ್ರಂದ್ರೆ ಏನಾಗುತ್ತೆ, law of mass action it will be depend upon the activity ಅಲ್ಲ. now activity, law of mass action ಅಂದ್ರೆ activity coefficient for the solution ಗೆ concentration ಅಲ್ಲಿ we can express. ಈಗ if it is in a pressure, if it is in a gaseous phase, it will be expressed in the law of mass action activity coefficient, it will be expressed in the pressure ಅಲ್ಲ. now ಈಗ equilibrium constant for this reaction ಹೆಂಗ್ ಬರ್ಬೋದು, K is equal to concentration of A into concentration of B, concentration of A and the concentration of B into concentration of AB ಅಲ್ಲ, concentration of AB. now This is the, what is this? This is the law of mass action applied for the above reaction. Now he has did the two experiments, one with the case 1 and the case 2. Now case 1 ಏನು ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ he has taken C moles of concentration in 1 liter of solution. Now he has did the experiment. Now C moles of concentration ತಗೊಂಡಿದ್ರೆ in 1 liter of solution. Here ಈಗ if he has applied a law of mass action, for a solution it can be expressed in the form of concentration ಅಲ್ಲ. Concentration ಅಂದ್ರೆ number of moles by volume in liter ಅಲ್ಲ, volume in liter. Now here the solution he has taken in the 1, so concentration will be equal to the number of moles only. So here AB gives rise to A plus B ಅಲ್ಲ. Now here initially he has taken the C concentration. Now 0. Now at a time t, equilibrium ಬಂದಾಗ from this C concentration, C minus alpha has been dissociated. Now here C alpha and the C alpha has been formed. Now here for this one, here he has applied the equilibrium constant. If he has applied, now then it will become concentration of A and the concentration of B. Now the concentration of AB ಅಲ್ಲ. Now concentration of A ಎಷ್ಟಿದೆ at equilibrium concentration of A ಎಷ್ಟಿದೆ C alpha and the concentration of B ಎಷ್ಟಿದೆ C minus C alpha ಅಲ್ಲ. Now this will be concentration of A is the C alpha, the concentration of the B is C alpha. Now concentration of AB ಎಷ್ಟಿದೆ C into 1 minus alpha ಅಲ್ಲ. Can I write like this? Here you can see. Now C into C alpha, right? C into C alpha. Can I write in this manner? C into C alpha, C minus C alpha, again the same it will become, right? Now ಇಲ್ಲಿ ನೋಡಿ. Now then it will become C square alpha square by C into 1 minus alpha ಅಲ್ಲ. Now 1 square 1 C will be get cancelled, then it will become alpha square by 1 minus alpha. Now ಇಲ್ಲಿ ನೋಡಿ. Now this is C alpha square. Now for a weak electrolyte, now this is weak electrolyte ಅಲ್ಲ. Now whatever we have taken, this is a weak electrolyte. Now for weak electrolyte 1 minus alpha will be tends to 1. ಹಿಂಗಂದ್ರೆ ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ 1 minus alpha is tends to 1 ಯಾಕಂದ್ರೆ now weak electrolyte ಅಲ್ಲಿ if you take A gives rise to A gives rise to B, let assume AB gives rise to B plus and the A minus if you take. Now illinda if 100 moles ತಗೊಂಡಿದೆ ಅಂದ್ರೆ 0.1 mole. Now the remaining will be the 99.9 mole has been in the form of reactant only. In comparison with the 99.9, now 0.1 dissociation is very less ಅಲ್ಲ. ಇಲ್ಲಿಂದ ನೀವು 99.9 number of moles of reactant, now dissociation ಎಷ್ಟು dissociation ಆಯಿತು 100 ಇಂದ only 0.1 dissociate ಆಯ್ತಲ್ಲ. in comparison with 0.1, in comparison with 100 with 0.1 is very less ಅಲ್ಲ. 0.1 is very less ಅಲ್ಲ. so ಅದಕ್ಕೋಸ್ಕರನೇ here alpha value for the weak electrolyte will be is negligible. ಈಗ ಇದು alpha value negligible ಮಾಡಿದೆವು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ C alpha square by 1 ಅಲ್ಲ, C alpha square by 1 means K is equal to C alpha square. If you bring the C to the left hand side ಏನಾಗುತ್ತೆ alpha square is equal to K by C. Now square if you bring it to the right hand side ಏನಾಗುತ್ತೆ alpha is equal to under root K by C. Now ಇಲ್ಲಿ ನೋಡಿ alpha is inversely proportional to the root C ಅಲ್ಲ. means if the alpha value increases, concentration will be decreases. If the alpha value increases, concentration decrease ಆಗುತ್ತೆ. Concentration decrease ಆಗುತ್ತೆ. Next, case 2. Now he has done now another experiment with the case 2. Now case 2 ಏನಂದ್ರೆ case 2 in this he has taken ಏನು ಮಾಡಿದ್ರು ಅಂದ್ರೆ here he has taken concentration 1 mole in V liters of solution. In V liters of solution. V liter of solution. Now value ಗೊತ್ತಿಲ್ಲ ಇಲ್ಲಿ. Now V value ತಗೊಂಡಿದ್ದಾರೆ. Now same. AB gives rise to A plus and the B minus. Initially time t ಅಲ್ಲಿ 1 mole ತಗೊಂಡಿದ್ರೆ now 0 0. At time t equilibrium ಅಲ್ಲಿ from the 1 mole 1 minus alpha has been dissociated. Now here concentration will be expressed in the volume because in the first equation ali here we have taken the 1 liter, but here the volume we don't know, some V value, so that's the reason we cannot neglect the volume V. Now means here alpha by V will be formed alla. Now equilibrium constant K is equal to alpha by V into 1 minus alpha by V alla. Then it will become alpha square by V square by 1 minus alpha into V. V will be get cancelled. Now the leftover will be the K is equal to alpha square by V into 1 minus alpha. V into 1 minus alpha. Now for the weak electrolyte, for the weak electrolyte 1 minus alpha will be equal to 1 alla, means this entire value will become equal to 1. Now K will be alpha square by V. Now alpha will be equal to under root K into V. ಈಗ ನೀವು alpha increase, degree of dissociation increase ಆಗಿದೆ ಅಂದ್ರೆ root V volume is also increasing ಅಲ್ಲ, means here degree of dissociation alpha value increase. Now root V is also increasing. Now Ostwald dilution law is applicable only for the weak electrolytes only. Now ಇಲ್ಲಿ ನೋಡಿ, now it is applicable only for weak electrolyte. It is applicable only for the weak electrolyte. Strong electrolyte Ostwald dilution law, it is not applicable. Okay, next. Common ion effect. Now common ion effect ಏನಂದ್ರೆ, common ion ಅಂದ್ರೆ the degree of dissociation of weak electrolyte is further suppressed by addition of strong electrolyte which is having common ion with weak electrolyte. This effect is known as a common ion effect. ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಫಸ್ಟ್ ಒಂದು ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ತಗೋತಾ ಇದ್ದೀನಿ. ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಯಾವುದು? ದಿಸ್ ಈಸ್ ವಾಟ್ ಇಸ್ ದಿಸ್? ಎಸ್ಟಿಕ್ ಆಸಿಡ್ ಇಸ್ ದ ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಲ್ಲ. ನಾವು ಇದು ಡಿಸೋಸಿಯೇಟ್ ಆದಮೇಲೆ ನಾವು ಎಸಿಟೇಟ್ ಅಯಾನ್ ಪ್ಲಸ್ H ಪ್ಲಸ್ ಅಲ್ಲ, H ಪ್ಲಸ್. Now here for this one acetic acid as well as the acetate ion and the H plus. Now this is a weak electrolyte. ಈ weak electrolyte ಗೆ ಇಲ್ಲಿ ನೋಡಿ, for this one ನಾನು ಹೇಳಿದ್ನಲ್ಲ, for 100 moles this has been dissociated into 0.1 mole. Now H plus ion also has been dissociated into 0.1 mole. Now for this one ಇಲ್ಲಿಗೆ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೇನೆಂದ್ರೆ, ಈ ಎಸಿಟಿಕ್ ಆಸಿಡ್ಗೆ ಒಂದು ಕಾಮನ್ ಅಯಾನ್ ಇರಬೇಕು, ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನಾನು ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆ, ನೌ ಹಿಯರ್ ಫಾರ್ ದಿಸ್ ಒನ್ ಐ ಆಮ್ ಆಡಿಂಗ್ ಒನ್ HCl ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಲ್ಲ. HCl ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಂದ್ರೆ ಈಗ ನಾನು 100 moles ಆಫ್ HCl ನಾನು ತಗೊಂಡಿದ್ದೀನಿ ಅಂದ್ರೆ, 100 moles ಆಫ್ HCl ತಗೊಂಡಿದ್ದೀನಿ ಅಂದ್ರೆ, means here 100 moles of Cl minus and the H plus ions means has been converted into here. When it has been converted into ions, now whatever the 100 moles of the strong electrolyte nanu ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀನಿ ಅಂದ್ರೆ now that it will be formed in 100 mole here. Now here also it will be formed in the 100 mole. ಇಲ್ಲಿ ನೋಡಿ, now here CH3 acetic acid ಅಲ್ಲ. Now here before adding the strong electrolyte, now acetic acid ಅಲ್ಲಿ H plus ion concentration ಎಷ್ಟು 0.1 ಅಲ್ಲ. Now when I add the strong electrolyte, ನಾನು strong electrolyte add ಮಾಡಿದಾಗ ಏನಾಯಿತು, H plus ion ಇದು ಟೋಟಲ್ ಸೊಲ್ಯೂಷನ್. ಈ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲೇ ಟೋಟಲ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ now let assume, now 1 minute, now see this bottle already, just assume ಈ ಬಾಟಲ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಎಸಿಟಿಕ್ ಆಸಿಡ್ ಇದೆ. ಈ ಬಾಟಲ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಎಸಿಟಿಕ್ ಆಸಿಡ್ ಇದೆ. now acetic acid has been converted into acetate ion and the H plus ion. Okay, means that is a weak electrolyte alla, weak electrolyte. Now for this acetic acid, now I was added the HCl which is having the common ion. now ಈ HCl ಗೆ ನಾನು HCl add ಮಾಡಿದ್ದೀನಿ, HCl add ಮಾಡಿದ್ದೀನಿ. now when HCl is a strong electrolyte alla, now ಎಷ್ಟು HCl ನಾನು add ಮಾಡಿದ್ರೋ that HCl, that moles of HCl will be converted into ions, that it will be converted into ions. Okay, now that it will be converted into ions alla, before adding H plus ion concentration is 0.1 mole. After the adding of the strong electrolyte, now H plus ion concentration, total solution H plus ion concentration ಎಷ್ಟಾಯಿತು 100.1 mole ಅಲ್ಲ, 100.1 mole. now acetic ion concentration ಎಷ್ಟಿದೆ 99.9 mole ಅಲ್ಲ, 99.9 mole. now here after adding the concentration ಎಷ್ಟಾಯಿತು total concentration 100.1 mole ಆಯ್ತಲ್ಲ, 100.1 mole. ಈಗ see after ಈಗ now after the adding the strong electrolyte, now which is having the common, now H plus ion concentration increase ಆಯ್ತಲ್ಲ, total H plus ion concentration increase ಆಯ್ತಲ್ಲ. ಇಲ್ಲಿ ನೋಡಿ the total H plus ion concentration, common ion concentration increase ಆಯ್ತಲ್ಲ, means ಈಗ ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಯ್ತಂದ್ರೆ ಈಗ ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿದೆ ಟೋಟಲ್ 100.1 mole. now ಇದರಲ್ಲಿ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿದೆ 99.9 ಅಲ್ಲ, ಮೀನ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ ಅಂದ್ರೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ವಿಲ್ ಶಿಫ್ಟ್ which direction, equilibrium will shift which direction. now the equilibrium will shift towards that direction where the concentration can be decreased. product side ಜಾಸ್ತಿ concentration ಇದೆ, reactant side concentration is less, means by the Le-Chatelier principle, by the Le-Chatelier principle, now by the adding of strong electrolyte which is common, now equilibrium shift towards backward direction. Okay, backward direction. ಈಗ ನೀವು ಕಾಮನ್ ಅಯಾನ್, ಈಗ ಏನಾದರೂ ಕಾಮನ್ ಅಯಾನ್ ನೀವು ಆ್ಯಡ್ ಮಾಡಿದ್ರು ಅಂದರೆ ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಜಾಸ್ತಿ ಆಗೋದಾದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಇರುತ್ತಲ್ಲ, ಸೊ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋಕೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ವಿಲ್ ಶಿಫ್ಟ್ ಟುವರ್ಡ್ಸ್ ದ ಎಷ್ಟು ಡೈರೆಕ್ಷನ್, ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ನೌ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ನೌ ದಟ್ ಇಸ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೌ ಈಗ ದಿಸ್ ಟೂ when weak electrolyte H plus ion concentration is to 0.1 alla. Now when you add the strong electrolyte, now H plus ion concentration is to 100 mole alla, 100 mole alla. Now in comparison with both, weak electrolyte H plus ion concentration is very very negligible alla in comparison with the strong electrolyte H plus ion concentration. Illi nodi strong electrolyte H plus ion concentration is to 100 mole. Weak electrolyte H plus ion concentration is to 0.01 mole. In comparison with the strong electrolyte H plus ion concentration, weak electrolyte H plus ion concentration is very very negligible alla, very very negligible alla. Means in comparison with, in the common ion effect, in comparison with strong electrolyte H plus ion concentration, weak electrolyte H plus ion concentration is negligible. Weak electrolyte H plus ion concentration is negligible. Is it clear? Okay. Next. Next, Herenius concept of acid base theory. Herenius concept of acid base theory alli we are having the three concept of Herenius acid base theory. Ondo Herenius acid base theory, next Bronsted-Lowry concept, next is the Lewis acids and the bases. Herenius acid base theory, Lewis acid bases. Now Lewis acid base and the Bronsted-Lowry concept. Now first Herenius acid base theory andre enandre illi first acids. Now here I am taking somewhat bases. Herenius acids and bases. First I am taking the Herenius acids and bases. Herenius acids and bases. Now the Herenius is the scientist, you know, ಏನು ಹೇಳಿದ್ರು ಅಂದ್ರೆ the one which gives H plus to the solution is acid. Now bases alli ಏನು ಹೇಳಿದ್ರು ಅಂದ್ರೆ one which gives OH minus to the solution is bases. Okay, ಈಗ H plus ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ಅದನ್ನು ಆಸಿಡ್, ಈಗ OH ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ಅದನ್ನು ಬೇಸ್, ಈ ಸೈಡ್ ಇಲ್ಲಿ ನೋಡಿ HCl gives rise to H plus Cl minus. Okay, it is giving H plus, so this is the acid. Next H2SO4. now ಇದರಲ್ಲಿ 2H plus it is giving plus SO4 minus 2. Okay, it is giving the 2H plus, idunu acid. This is what is this? Sulfuric acid. Now next, but ನೀವು ಈಗ ಸೋಡಿಯಂ ಬೈಕಾರ್ಬೋನೇಟ್ ತಗೊಂಡಿದ್ದು ಅಂದ್ರೆ ನಾವು ದಿಸ್ ಸೋಡಿಯಂ ಬೈಕಾರ್ಬೋನೇಟ್ ಏನಾಗುತ್ತೆ? ಡಿಸೋಸಿಯೇಟ್ Na ಪ್ಲಸ್ ಪ್ಲಸ್ H ಪ್ಲಸ್ ಪ್ಲಸ್ CO3 minus 2 ಅಲ್ಲ, CO3 minus 2. ಇಲ್ಲಿ ನೋಡಿ this sodium bicarbonate is a salt. ಇದು salt. ಈಗ this is also giving the H plus. Sodium bicarbonate no H plus ಕೊಡ್ತಾ ಇದೆ. Now why this is not the acid? Why it is not the acid? This was not explained by the Herenius. So that's the reason this concept has been, this was not explained by the Herenius. So next we are going to see the Bronsted-Lowry acid base theory. Now ಇಲ್ಲಿ ನೋಡಿ bases ಅಲ್ಲಿ NaOH ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ತಗೊಂಡಿದ್ದಂದ್ರೆ Na plus and the OH minus, Na plus and the OH minus. Now that is the base. Okay, fine. Now ಇಲ್ಲಿ ನೋಡಿ calcium oxide, next magnesium oxide, next Na2O. These all are the strong bases. Now ಇದರಲ್ಲಿ in these three there is no OH. There is no OH. Idralli there is no OH. Even though these are the strong bases. These are the strong bases. Now, even though it is not having the OH, that all are the strong bases, which was not explained by the Arrhenius. Which was not explained by the Arrhenius. Next. Next. Bronsted-Lowry acid-base theory. Bronsted acid-base theory. Now, what is explaining? What is explaining? Now, one which donates H plus, one which donates H plus is acid. Now, one which accept H plus, one which accept H plus is base. He said one which donate the H plus is the acid, one which accept the H plus is a base. Now, illinda one example tagota idini nanu. HCl plus H2O gives rise to hydronium ion plus Cl minus. Now, illi nodi, now H2O has accepted the H plus. H2O is accepted the accepted. Now, H2O accepted the H plus. Now, H2O has accepted the H plus alla. Now, the one which accept the H plus is base. Andre, now H2O is base. H2O is base. Now, HCl H ಕೊಟ್ಟಿದ್ರಲ್ಲ, HCl H ಕೊಟ್ಟಿದ್ರಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನ HCl is acid. HCl is acid. HCl is acid. See ಇಲ್ಲಿ ನೋಡಿ. Now, HCl ಅಲ್ಲಿ H ಕೊಟ್ಟಿದ್ರಲ್ಲ, that's the reason this is acid. H2O is accepting the H plus, ಅದಕ್ಕೋಸ್ಕರ this is base. Now, here this acid, it has been given the H plus and formed as a Cl minus. Means this is a strong acid. This is a strong acid. This is a strong acid. Now this Cl minus ಏನು? Strong acid ಗೆ Cl minus ಏನು? Conjugate base. This is conjugate base. This is conjugate base. Strong acids HCl ಅಲ್ಲಿ Cl minus is a conjugate base. No. This is base alla. Base, this has been accepted. This has been accepted the H plus, and this is a conjugate acid. This is a conjugate acid. This is a conjugate acid. Okay. Now ಇಲ್ಲಿ ನೋಡಿ, HCl strong acid, Cl minus is a conjugate base. Now H2O it has accepted the H plus alla. Now base. ಈ base ಗೆ this H3O hydronium ion is a conjugate. This is hydronium ion. This is a conjugate acid. Okay. Now next example. If I am taking here I am taking NH3 plus H2O gives rise to ammonium ion plus ammonium ion. Next it will be given as a OH minus. Ammonium ion and the OH minus. Now ಇಲ್ಲಿ ನೋಡಿ, ammonia has been accepted the what it has been accepted? It has been accepted the H plus alla. Means H2O has given the H plus. H2O has been given the H plus. Andre H2O here it is a acid. H2O it is a acid. Now acids OH minus is a conjugate base. Conjugate base. To conjugate base. Now ammonia, it has been given H plus Allah, that's the reason it is acid. Ammonia, it has been accepted. Ammonia, it has been accepted H plus Allah, so this is a base. Now this is a base. Now this is accepted. This is accepted the proton, that's the reason this is conjugate acid. Conjugate acid. This is the conjugate acid. Now this is a conjugate base. Okay. Now how to identify? Heng identify ಮಾಡಬಹುದು ಅಂದ್ರೆ this conjugate acid and the conjugate base from the molecule or from the substance, if the H plus has been lost, now the remaining ion will be the conjugate base for it. Now ಇಲ್ಲಿ ನೋಡಿ HCl. Now HCl ಗೆ this is, let assume this is acid. Now acid's conjugate base. Acid's conjugate base will be. Acid's conjugate base will be. Conjugate base. Now from the HCl, if the H plus has been lost, now the remaining will be the Cl minus Allah. Now HCl, the conjugate base will be the Cl minus. HCl ge conjugate base will be the Cl minus. Now H2SO4. H2SO4 ge conjugate base ಏನಂದ್ರೆ HSO4 minus. HSO4 minus. HSO4 minus. Now next this HSO4 minus ge conjugate base ಏನಂದ್ರೆ SO4 minus 2. SO4 minus 2. SO4 minus 2. Now here this HSO4 minus will act as a amphoteric. This act as a amphoteric. ಇದು ಕಾಂಜುಗೇಟ್ ಆಸಿಡ್ ತರನು ಆಕ್ಟ್ ಮಾಡ್ತಾರೆ ಮತ್ತೆ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ತರನು ಆಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತಾರೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಫ್ ಇಟ್ ಈಸ್ ಆಕ್ಸೆಪ್ಟ್ ದ H ಪ್ಲಸ್, ಇಫ್ ಇಟ್ ಈಸ್ ಆಕ್ಸೆಪ್ಟ್ ದ H ಪ್ಲಸ್ ಏನಾಗುತ್ತೆ H2SO4. H2SO4 ಅಲ್ಲ, ಮೀನ್ಸ್ by accepting the H plus, it is acting as a, by accepting the H plus it is acting as a what? Conjugate acid. Now here it can lose the H minus, it can lose here, it can lose the H plus, then it can if it is lost the H plus, it will be formed as a SO4 minus 2. If it is accept the H plus, it will form the H2SO4. Here HSO4 minus, you have to be seen very carefully. You have to be see very carefully. HSO4, which is a conjugate acid, means H2SO4. HSO4 minus, which is a conjugate base, means SO4 minus 2. If they ask conjugate base, here ಏನಾದರೂ ಮಾಲಿಕ್ಯೂಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, ಏನಾದರೂ ಆಸಿಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, ಈಗ ಅಲ್ಲಿಂದ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಅಲ್ಲಿಂದ ಒಂದು H ಪ್ಲಸ್ ರಿಮೂವ್ ಮಾಡಿ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬರಿದೀವಲ್ಲ HCl ಅಲ್ಲಿ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಏನು Cl ಮೈನಸ್, ಇಲ್ಲಿಂದ ನಾನು H ರಿಮೂವ್ ಮಾಡಿದ್ದೀನಿ. H ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಇನ್ನೇನು ಬರುತ್ತೆ Cl ಮೈನಸ್ ಅಲ್ಲ, ಆ Cl ಮೈನಸ್ ಇಸ್ ಅ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಫಾರ್ ದಟ್ ಆಸಿಡ್. ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಫಾರ್ ದಟ್ ಆಸಿಡ್. ನೌ ಪರ್ಕ್ಲೋರಿಕ್ ಆಸಿಡ್ HClO4. ನೌ ಫಾರ್ ದಿಸ್ HClO4 ಗೆ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಏನು? ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಏನು? ClO4 minus. ClO4 minus is a conjugate base for this one. This is a conjugate base. Conjugate base. Okay. Now this is a conjugate base. Now next ammonia. ಅಮೋನಿಯಾಗೆ ಈಗ ನಾನು ಒಂದು H ಪ್ಲಸ್ ರಿಮೂವ್ ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ H2 minus. This is a conjugate base. Now ಅಮೋನಿಯಾಗೆ ನೆಕ್ಸ್ಟ್ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ನೋಡಿದ್ವಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಕಾಂಜುಗೇಟ್ ಆಸಿಡ್ ವಿಲ್ ಸಿ. ಕಾಂಜುಗೇಟ್ ಆಸಿಡ್ ಏನಂದ್ರೆ ಸಿ, ನಾವು ಹಿಯರ್ NH3 ಇದೆಯಲ್ಲ, NH3 ಗೆ ಇಫ್ ಯು ಆಡ್ ಒನ್ H ಪ್ಲಸ್, ನಾವು ಏನಾಗುತ್ತೆ NH4 ಪ್ಲಸ್ ಅಲ್ಲ, NH4 plus. Now this is a conjugate acid for this one. Now next HSO4 minus. HSO4 minus ಗೆ ನೀವು ಒಂದು ಹೈಡ್ರೋ H ಪ್ಲಸ್ ಆಡ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ H2SO4 ಅಲ್ಲ. Now this is a HSO4 minus ಗೆ ಕಾಂಜುಗೇಟ್ ಆಸಿಡ್ ಏನು H2SO4. H2SO4. Now Cl minus ಇದೆ. Cl minus. For Cl minus ಗೆ ನೀವು ಒಂದು H plus add ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ HCl. Cl minus conjugate acid will be the HCl. Okay. Now these are the examples for the conjugate acid and the conjugate bases. Okay. Lewis acid base theory. Lewis acid base theory ಅಂದ್ರೆ ಏನಂದ್ರೆ Lewis acid base theory. Lewis acid base theory means ಇಲ್ಲಿ electron pair acceptors are acids, electron pair donors are bases. Now Lewis acids alli electron pair acceptors are acids, electron pair donors are the bases. Now electron Lewis acids ಯಾವುದು, Lewis bases ಯಾವುದು ನಾನು ನೋಡಿ. ಫಸ್ಟ್ Lewis acids ಫಸ್ಟ್ Lewis acids ಅಲ್ಲಿ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ all cations are Lewis acids. All cations are the Lewis acids. H plus Na plus so on. These all are the Lewis acids. All the cations are the Lewis acids. Next, central atom electron deficient or if the octet is not completed, that also we call it as a Lewis acid. Central atom electron deficient. Example BX3 andre here X is the fluorine, chlorine, bromine and the iodine. Now electron deficient species or central atom it is having its octet is not completed. Now that is MgCl2, BeCl2. Now these are the examples. Now these also will act as a Lewis acid. Next, central atom having vacant d orbital. If the central atom is having the vacant d orbital, those also will act as a Lewis acid. Example PCl5. Now next SCl6. Now these are the examples. Now PCl5 ಅಲ್ಲಿ ಇಲ್ಲಿ ನೋಡಿ PCl5 electronic configuration ಎಷ್ಟು, electronic configuration is a 15 ಅಲ್ಲ, means this is neon 3s2 3p 3 ಅಲ್ಲ, and the 3d is empty, right? Now 3d is empty. For that reason the empty d orbital, due to the presence of vacant d orbital, now it can accept the electron in the d orbital. Now phosphorus d orbital ge electron accept ಮಾಡುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರನೇ now central atom having the vacant d orbital ಅದನ್ನು Lewis acid, it will act as a Lewis acid. SCl6 sulfur electronic configuration ಏನು 16 ಅಲ್ಲ. Now this is neon 3s2 3p4, same vacant d orbital ಇರುತ್ತೆ sulfur ಗೆನು, so that's the reason it is acting as a Lewis acid. Next, Lewis bases. Now what are the Lewis bases? All anions are Lewis bases. All anions are the Lewis bases. Okay. Next, here next, if lone pairs are present, if lone pairs are present, it act as Lewis bases. It acts as Lewis bases. Lone pair, if the lone pair is present, it acts as a Lewis bases. Example, NH3. Next, primary alcohol. Next, ROR. Now, due to the presence of this lone pair, it will donate the electron pair. This will donate the electron pair to the electron deficient species. Adhigoskarane, these will act as a Lewis bases. Now, Cl minus, I minus, now Br minus. Now, this will be act as a Lewis. All the anions will act as a Lewis bases. Now, ಇಲ್ಲಿ ನೋಡಿ. Now, Lewis bases are Lewis bases. Now, Lewis bases will act as a nucleophiles. No, Lewis acids will act as a electrophiles. Okay, electron deficient species. Electrophiles are the electron deficient species. Nucleophiles are the electron sufficient species. It will donate the electron. Now, electrophiles will accept the electron. Now, next. Ionic product of water. Ionic product of water andre enandre, here ionic product of the water andre, see, a pure water is very weak electrolyte. Very weak ionic product of the water. Now, pure water is a what? Very weak electrolyte. Very weak electrolyte andre H2O. Weak electrolyte alla. Weak electrolyte ande it will not completely dissociate. Partially dissociate. Now, H plus and the OH minus. Now, if you apply the law of mass action for this one, now equilibrium constant heng barabodu? K is equal to concentration of H plus and concentration of OH minus alla by concentration of H2O, right? Now, illi nodi. Now, H2O is a pure, it is very weak electrolyte alla. Very weak electrolyte andre illinda 100 moles of H2O tagondidde andre 0.01 mole has been converted into ions. Andre the remaining will be in the products, remaining will be in the reactants alla. Andre concentration of H2O, it is negligible alla. Means if you take this concentration, one equilibrium concentration and the concentration of H2O will give the concentration of H plus and the concentration of OH minus. Now, here one constant and this is another constant, and this combines to give the new constant, that is Kw. Ionic product of the water will represent with the Kw. Kw is equal to concentration of H plus and the concentration of OH minus. Concentration of H plus and the concentration of OH minus, or we can write it in this form also, concentration of ammonium ion, concentration of hydronium ion and the OH minus. Now, Kw of water is equal to ionic product of the water. Ionic product of the water are, now Kw is equal to concentration of H plus and the concentration of OH minus. Concentration of H plus and the concentration of OH minus. Now, here this point is very, very important. Kw depends only on temperature. Kw will depends only on the temperature. This point is very, very important. Okay. Now, Kw is this is a ionic product of water. This is ionic product of water, product of water. This is a ionic product of water. Okay, now iga this pure water is a very weak electrolyte. Yakandre why this is very weak electrolyte, nanu that derivation maditini. Now I will show it. By solving that derivation you will get to know how much dissociate, how much alpha value it has been dissociate. By that you will get to know now why the H2O is a pure or weak electrolyte. Now illi nodi, now experimentally this value is experimentally they have given, this value is experimentally they have given, experimentally now pure water experimentally pure water at 25 degrees, at 25 degrees Kw ionic product of water, Kw is equal to 10 to the power minus 14 meter square, sorry molar square, 10 to the power minus 14 molar square. This is experimentally they have given, experimentally they have given. Now experimentally they have given, right, at 25 degrees centigrade, at 25 degrees centigrade. Now at room temperature Kw is equal to 10 to the power minus 14 molar square, sorry molar square alla. Now here in pure water now concentration of H plus will be equal to concentration of OH minus is equal to Kw alla. Now Kw ionic product of water alli how many H plus ion concentration irutto adralli the same OH minus concentration iruttala. Means see, if concentration of H plus and the concentration of the OH minus I am taking X, let assume let concentration of H plus and the concentration of OH minus I am taking it as a X. Now illi Kw is equal to concentration of H plus and the concentration of OH minus alla. Now Kw at 25 degrees centigrade in pure water at 25 degrees I am finding. Now Kw concentration of H plus and the OH minus at 25 degrees S2 Kw 10 to the power minus 14 molar square alla, molar square. Now here concentration of the H plus and the concentration of the OH minus is to tagondidini X into X, here X and here X. Now this will be equal to X square alla, X square is equal to 10 to the power minus 14 molar square. Now ಈಗ ನಾನು square if I take it to the right hand side ಏನಾಗುತ್ತೆ, X is equal to 10 to the power minus 7 molar, minus 7 molar ಅಂದ್ರೆ at 25 degrees centigrade. ನಾವು ಪ್ಯೂರ್ ವಾಟರ್ ಅಲ್ಲಿ H plus ion concentration ಮತ್ತೆ OH minus ion concentration ಎಷ್ಟು 10 to the power minus 7, 10 to the power minus 7. Kw is equal to now concentration of H plus and the concentration of OH minus at 25 degrees centigrade. At 25 degrees centigrade pure water ಅಲ್ಲಿ H plus ion concentration ಎಷ್ಟು X ಅಲ್ಲ. now OH minus ion concentration ಎಷ್ಟು 10 to the power minus 7 molar and ಇದರಲ್ಲಿ 10 to the power minus 7 molar, 10 to the power minus 7 molar and the 10 to the power minus 7 molar. Okay, H plus ion concentration is 10 to the power minus 7 molar and the OH minus ion concentration is to 10 to the power minus 7 molar, 10 to the power minus 7 molar. Pure water ಅಲ್ಲಿ at 25 degrees pure water ಅಲ್ಲಿ ಎಷ್ಟು concentration ಇರುತ್ತೆ H plus ion concentration 10 to the power minus 7, OH minus ion concentration ಎಷ್ಟು ಇರುತ್ತೆ 10 to the power minus 7 molar, 10 to the power minus 7 molar. Now next ಇಲ್ಲಿ ನೋಡಿ 10 to the power minus 7 molar, 10 to the power minus 7 molar ಅಲ್ಲ. in 1 liter of solution, in the 1 liter of H2O, in 1 liter of H2O now having 10 to the power minus 7 molar of H plus ion concentration. Okay, now in 1 kg of H2O having 10 to the power minus 7 molar H plus ion concentration. Okay, now in 55.5 mole of H2O is also contain 10 to the power minus 7 molar of H plus ion concentration. Now in 1 liter alli no 10 to the power minus 7, 1 kg alli no 10 to the power minus 7, 55.5 mole alli no 10 to the power minus 7 molar of H plus ion concentration irutte. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ನಾವು density of pure water, now ionic product of water ಅಲ್ಲಿ ನಾನು ಏನು ತಗೊಂಡಿದ್ದೀನಿ, ಪ್ಯೂರ್ ವಾಟರ್ ಅಲ್ಲ, ಡೆನ್ಸಿಟಿ ಆಫ್ ಪ್ಯೂರ್ ವಾಟರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 gram per ml or 1 liter, sorry 1 kg per liter, 1 kg per liter, kg per liter or 1 gram per ml. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ 1 liter ಅಲ್ಲಿ 1 kg ಇರುತ್ತಲ್ಲ. now if I convert it into the grams, it will be a 1000 grams ಅಲ್ಲ, 1000 grams. 1 liter ಅಲ್ಲಿ 1000 grams of 1 liter is 1 liter, it is having the 1000 grams of H2. means here 1 mole contain 18 grams of H2 alla. means in 1000 grams how many moles will be there, how many x is equal to 1000 by 18 alla, means it will be equal to 55.5 mole. means 1 liter of pure water alli ಎಷ್ಟು moles ಇರುತ್ತೆ 55.5 mole. now here 55.5 mole alli H plus ion 1 liter contain 10 to the power minus 7 molar of H plus ion concentration. 55.5 moles also having the 10 to the power minus 7 molar concentration alla. ಇಲ್ಲಿ ನೋಡಿ 1 liter of pure water contain 55.5 moles of H plus ion concentration, or 1 liter of H2O contain 55.5 moles of water. now ಇಲ್ಲಿ same, now 55.5 moles contain 10 to the power minus 7 moles of H plus ion concentration. if 55.5 moles having 10 to the power minus 7 molar concentration of H plus, then 1 mole contain, from the 55.5 moles, now 10 to the power minus 7 molar of concentration of from the 55.5 moles of pure water alli H plus ion minus OH minus ion ಕೊಡ್ತಿದಲ್ಲ. now ಅದರಲ್ಲಿ H plus ion concentration ಎಷ್ಟು 10 to the power minus 7, now 55.5 mole ಅಲ್ಲಿ ನಾನು 1 mole ಅಲ್ಲಿ find out ಮಾಡು. I want to find for 1 mole how much H plus ion concentration it will be give. okay, now ಈಗ 55.5 mole ಗೆ 10 to the power minus 7 molar of H plus ion concentration ಕೊಡ್ತಾ ಇದೆ. but for 1 mole ಗೆ ಎಷ್ಟು concentration of H plus ion concentration ಕೊಡುತ್ತೆ ಅಂತ ನಾನು find out ಮಾಡ್ತಾ ಇದ್ದೀನಿ. now see how much it will give, now x is equal to now 10 to the power minus 7 55.5 mole. now ಈ ತರನು ಬರಿಬೋದಲ್ಲ, 1000 by 18 means 10 raised to 3 by 18, 10 raised to 3 by 18. now if you take the 18 to the upside, then what happened, 18 into 10 to the power minus 10, then it can be 10 to the power minus 9 ಅಲ್ಲ. means ಇಲ್ಲಿ ನೋಡಿ 55.5 moles of water ಅಲ್ಲಿ 10 to the power minus 7 concentration of H plus ion is ionizing. now 1 mole ಅಲ್ಲಿ ಎಷ್ಟು concentration of H plus ion it is ionizing, 1.8 into 10 to the power minus 9. 10 to the power minus 9 ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ 10 to the power minus 9 ಅಂದ್ರೆ value will be very less ಅಲ್ಲ, very less ಅಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರನೇ pure water is a very weak electrolyte. alpha degree of dissociation at 25 degrees, degree of dissociation of pure water at 25 degree is how much, 1.8 into 10 to the power minus 9. 10 to the power minus 9 molar. 10 to the power minus 9 molar. Okay, so the degree of dissociation of the alpha value at 25 degrees, this is very less, very less. Adhigoskarane why? Pure water is very weak electrolyte. Okay, now next, power of hydrogen. Power of hydrogen enandre, power of hydrogen in pH. pH, the power of hydrogen, for this we are having the direct formula. Now direct formula enandre, pH is equal to minus log of H plus ion concentration. Now for the POH, minus log of OH minus ion concentration. OH minus ion concentration. If you want the H plus ion concentration, H plus ion concentration is equal to 10 to the power minus pH. Now if you want the concentration of OH minus ion, now this will be equal to the 10 to the power minus OH minus ion concentration. OH minus ion concentration. Now ನೀವು ಈಗ pH ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ ಎಷ್ಟು ಫಾಸ್ಟ್ ಆ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಅಂದರೆ, ಇಲ್ಲಿ ನೋಡಿ, ಇಫ್ H plus ion, if the H plus ion concentration, question ಅಲ್ಲಿ if the H plus ion concentration x 10 to the power minus x ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, 10 to the power minus x ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, then the pH will be, then the pH is equal to x. Then the pH will be equal to, ಇದರಲ್ಲಿ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ x ಇರುತ್ತೋ the pH value will be that one. Now next, if H plus is equal to x into 10 to the power minus y, 10 to the power minus y, ಈ ಥರ ಈಗ H plus ion concentration ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ನಾನು ಈ ಎರಡು ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ನಾನು ಕ್ವಶನ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಜಸ್ಟ್ ಯು ಸಿ, then pH will be equal to, y minus log x, this is very important. Now these two are very important to solve. Now to solve the pH question, fast solve madoke, if you remember this two, you can solve the questions very fastly. Next, considering the relation. Now the relation of the Kw and the pH. Now considering relationship, now ಇಲ್ಲಿ ನೋಡಿ, considering the relationship, now ionic product of the water Kw, concentration of H plus and the concentration of OH minus is equal to Kw. Ionic product of water Kw, ionic product of water at experimentally ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು, 10 to the power minus 14 at 25 degrees ಅಲ್ಲ, at 25 degrees. Now for this one, the above reaction ಗೆ applying log on both side, apply log on both side ಏನಾಗುತ್ತೆ, log H plus ion concentration plus log OH minus ion concentration is equal to log Kw is equal to log 1 into 10 to the power minus 14 ಅಲ್ಲ, 10 to the power minus 14. Now here we are having pH is equal to minus log H plus ion concentration ಅಲ್ಲ. Now POH is equal to minus log OH minus ion concentration ಅಲ್ಲ. Now PKW is equal to minus log concentration of KW. Now ಎವೋ ರಿಯಾಕ್ಷನ್ಗೆ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಅಪ್ಲೈ ನೆಗೆಟಿವ್ ಆನ್ ಬೋತ್ ಸೈಡ್ಸ್, log A into B, here log a into b ಏನಾಗುತ್ತೆ log a plus log b. Okay, don't get confused. Now ಇಲ್ಲಿ ನೋಡಿ, now next log H plus ion concentration plus minus log OH minus ion concentration, next minus log Kw is equal. Now here it is minus log 10 to the power minus 14, minus into minus 14 ಎಷ್ಟಾಗುತ್ತೆ 14 ಅಲ್ಲ. ಸಿ ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಮೈನಸ್ ಲಾಗ್ H plus ion concentration ಅಂದರೆ pH plus minus log OH minus ion concentration POH minus log Kw means PKW is equal to 14 ಅಲ್ಲ at 25 degrees, at 25 degrees. Now this is a very very important formula. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ. ಈ ಥರನೂ ಬರಿಬೋದು, pH plus POH is equal to 14 at 25 degree centigrade, at 25 degree centigrade. Okay, now pH plus POH is equal to 14 at 25 degree centigrade, at 25 degree centigrade. Now we'll see some questions on this, we'll see some questions on this now. If find right, taken that, find pH in aqueous solution, in aqueous solution at 25 degrees. Now here 0.05 molar of HCl in aqueous solution. Find pH, find pH. Now ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು ಅಂದರೆ, ಹಿಯರ್ HCl ಅಲ್ಲಿ H plus ಇರುತ್ತಲ್ಲ, now here the concentration of H plus will be equal to 0.05, ಈ ಥರನೂ ಬರಿಬೋದಲ್ಲ, 5 into 10 to the power minus 2, 10 to the power minus 2. here ಇಲ್ಲಿ ನೋಡಿ H plus ion concentration ಎಷ್ಟು 10 to the power minus 2. he is asking in the aqueous solution ಅಲ್ಲ, aqueous solution. Find the 0.05 m of HCl in aqueous solution, find the pH. aqueous solution ಅಲ್ಲಿನೂ H plus ಇರುತ್ತಲ್ಲ, aqueous solution ಅಲ್ಲಿನೂ H plus ಇರುತ್ತಲ್ಲ, aqueous solution ಅಲ್ಲಿ H plus ion concentration ಎಷ್ಟು 10 to the power minus 7 molar ಅಲ್ಲ, 10 to the power minus 7 molar. ನಾವು ಇದರಲ್ಲಿ HCl H plus ion concentration ಎಷ್ಟು 10 to the power minus 2. Now comparative to the 10 to the power minus 2, comparative to the 10 to the power minus 7, 10 to the power minus 7 concentration is less, right? Now ಇಲ್ಲಿ ನೋಡಿ, in compare with aqueous solution, H plus ion concentration is 10 to the power minus 7 molar. Now HCl H plus ion concentration is 10 to the power minus 2 molar. Now 10 to the power minus 2 molar is higher than the 10 to the power minus 7 molar alla. Now in comparison with 10 to the power minus 2 molar, 10 to the power minus 7 is negligible. 10 to the power minus 7 molar is negligible alla. Adigoskarané we are not taking the H plus ion concentration. We are not taking the H plus ion concentration. Here the pH is equal to minus log of H plus ion concentration, right? H plus ion concentration ಎಷ್ಟಿದೆ minus log. Now 5 into 10 to the power minus 2, 5 into 10 to the power minus 2. ನಾನು ಇಲ್ಲೇ ಹೇಳಿದ್ನಲ್ಲ, what I said, if the concentration, if the H plus ion concentration is in the form of x into 10 to the power minus 5, pH will be y minus log x, y minus log x. See, it is also in the form of y, it is also in the form of x into 10 to the power minus y alla, then it will be equal to y minus log x alla, means 2 minus log 5, 2 minus log 5. Now here what is the answer? In comment box alli comment ಮಾಡಿ, the comment box alli comment ಮಾಡಿ, what is the answer ಅಂತ ನೀವು ಒಂದ್ಸರಿ comment box alli comment ಮಾಡಿ, you will get the answer. Now next question. He has given 0.05 molar of NaOH, find pH. 0.05 molar of NaOH in aqueous solution, find the pH. Now here the NaOH is the base alla, means POH is equal to minus log of OH minus ion concentration. OH minus ion concentration is to OH minus ion concentration is equal to 5 into 10 to the power minus 2 molar. Okay, now here same, this will be equal to 2 minus log 5, 2 minus log 5. ಇಲ್ಲಿಂದ OH minus ion concentration ನಿಮಗೆ ಬರುತ್ತೆ, ಇಲ್ಲಿಂದ OH minus ion concentration ಬರುತ್ತೆ. ಈಗ ನಿಮಗೆ ಇಲ್ಲಿಂದ OH minus ion concentration ಬರುತ್ತಲ್ಲ, ನೆಕ್ಸ್ಟ್ ನೀವಿಂಗ ಪಿ ಎಚ್ ಹೆಂಗೆ ಫೈಂಡ್ ಮಾಡ್ಬೋದು ಅಂದರೆ, ನಾವು ಈಗ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಫಾರ್ಮುಲಾ ಅಲ್ಲ, ಪಿ ಎಚ್ ಪ್ಲಸ್ ಪಿ ಒ ಎಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 14, ಪಿ ಎಚ್ ಪ್ಲಸ್ ಪಿ ಒ ಎಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 14. ನಾವು ಇಲ್ಲಿಂದ ಪಿ ಒ ಎಚ್ ವಿ ಗಾಟ್ ಇಟ್ ರೈಟ್, ಸಾರಿ ಇಲ್ಲಿಂದ ಇದು ಪಿ ಒ ಎಚ್, ದಿಸ್ ಈಸ್ ಪಿ ಒ ಎಚ್. ಓಕೆ, ನಾವು ಇಲ್ಲಿಂದ ನಿಮಗೆ ಪಿ ಒ ಎಚ್ ಗಾಟ್ ಇಟ್ ಅಲ್ಲ. Now here the pH is equal to 14 minus whatever the POH value we got, in the pH. Now here what is the pH value, anta neevu sari comment box alli comment maadi. Okay, see here also we are not taking the OH minus ion concentration. Aqueous solution alli OH minus ion concentration ಎಷ್ಟು ಇರುತ್ತೆ, 10 to the power minus 7 molar ಅಲ್ಲ. In comparison with the 10 to the power minus 7, in comparison with the 10 to the power minus 2, 10 to the power minus 7 molar is very negligible alla. Adikoskarane we are not taking the concentration of OH minus ion. Now this question, you see, this question is very very important. Now illi nodi, now in find the pH of if HCl, if HCl concentration is 10 to the power minus 7 molar, if HCl concentration, if the HCl is 10 to the power minus 7 concentration in aqueous solution, find pH. Now ಇಲ್ಲಿ ನೋಡಿ, the find pH ಅಲ್ಲ. Now HCl H plus ion concentration ಎಷ್ಟು, 10 to the power minus 7 molar, 10 to the power minus 7 molar. In aqueous solution ಅಲ್ಲಿ H plus ಇರುತ್ತಲ್ಲ, ಅದನ್ನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು, 10 to the power minus 7 molar. ಇಲ್ಲಿ ನೋಡಿ 10 to the power H plus ion concentration 10 to the power minus 7, H plus ion concentration 10 to the power minus 7 ಅಲ್ಲ. So we cannot neglect the aqueous solution H plus ion concentration. So here what we have to do, now H plus ion concentration, what we have to do, we have to add H plus ion concentration of HCl, H plus ion concentration of HCl and the H plus ion concentration of the H2O. Means here 1 into 10 to the power, then it will become 2, 10 to the power minus 7 alla, then it will become 2 into 10 to the power minus 7 molar, 10 to the power minus 7 molar. We are having a 10 to the power minus 7, 10 to the power minus 7, right? Now the 2 we are having, right? 2 into 10 to the power minus 7 molar. Now find the pH. pH is equal to minus log H plus ion concentration alla, minus log H plus ion concentration. Now this is log into 2 into 10 to the power minus 7, 10 to the power minus 7. Now this is in the form of x into 10 to the power minus y alla, then it will become 7 minus log 2, 11 minus log 2. Log 2 value is to, it is approximately equal to 0.3. 7 minus 0.3, it will be equal to 6.69 something. Okay, now this is the, ಇಲ್ಲಿ ನೋಡಿ ಈಗ 10 to the power minus 7, 10 to the power minus 6 ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದರೆ we should not neglect the H plus ion concentration. ಈಗ if the H plus ion concentration 10 to the power minus 2 ಕೊಟ್ಟಿದ್ದೀರ ಅಂದರೆ ಇಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ನಾವು ಇಲ್ಲಿ H plus ion concentration ಎಷ್ಟು 10 to the power minus 2 ಅಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನೇ we are not consider the 10 to the power minus 7 aqueous solution concentration. ಇಲ್ಲಿ ನೋಡಿ, now here the concentration is 10 to the power minus 7. In comparison aqueous solution ಅಲ್ಲಿ 10 to the power minus 7 concentration ಇರುತ್ತಲ್ಲ, in comparison with the 10 to the power minus 7, 10 to the power minus 7 concentration is same. ಈಗ ಇಲ್ಲಿಂದ 10 to the power minus 6 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದರೆ ಅಲ್ಲಿನೂ H plus ion concentration we have to take. Okay, in comparison with the 10 to the power minus 6, 10 to the power minus 7 concentration is almost nearer to the equal alla, so we should not be neglect. Okay, now by this ionic equilibrium lecture 1 ಮುಗಿತು. now ಈಗ ನಾನು ಒಂದು ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, ಆ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಆನ್ಸರ್ ನೀವು ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಕಾಮೆಂಟ್ಸಲ್ಲಿ ನೋಡ್ತೀನಿ. ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ. ವಿಲ್ ಸಿ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಲೆಕ್ಚರ್.